Well, I think that there's increasingly a convergence actually between SpaceX and Tesla and XAI. It's going to be, I think, if you can think of it, you can have it, will be the future. Then I would say that's probably a good company to invest in. When Tesla is doing simulations for self-driving.
For years, the electric vehicle industry lived by one unspoken rule. You could build a car that was fast, or you could build a car that was efficient, but you could not have both. Every engineer who tried to break that rule ran into the same wall. The push for more power, and the motor overheated, the range collapsed, and the cooling system ballooned in size and cost. The push for efficiency instead, and the car felt sluggish, stripped of the thrill that made electric performance exciting in the first place. That trade-off wasn't treated as a challenge to be solved. It was treated as physics, a boundary nobody could push past. And then, quietly, without a stage presentation or a flashy unveiling, Tesla's engineers handed over a piece of hardware that seemed to ignore the rule entirely. It didn't happen overnight. To understand why this motor matters, you have to go back to a time when almost nobody believed Tesla could hold its early lead. When the company first started climbing, the giants of the auto world barely blinked. Ford, General Motors, Toyota, Volkswagen. These were companies with a century of manufacturing muscle behind them, deep supply chains, and factories that could stamp out cars by the millions. Tesla, by comparison, looked like a science project that had gotten lucky. The assumption inside boardrooms across Detroit, Wolfsburg, and Toyota City was simple. Give it time, and the traditional players will catch up and swallow this upstart whole. For a stretch, that prediction looked reasonable. Rival electric vehicles got better. Battery packs improved faster than expected. Design language matured. Analysts started writing headlines suggesting Tesla's window was closing, that its head start had simply been a head start, not a permanent advantage. The narrative wrote itself. The disruptor disrupts, and then the incumbents absorb the lesson and move on. Except that isn't what happened. While the rest of the industry was busy admiring how close it had gotten, Tesla was working on something almost nobody outside its own labs knew about, a motor built around a completely different set of assumptions. At the center of that motor sits a component that sounds almost too simple to matter, a carbon fiber wrapped rotor. To understand why it's such a big deal, you need to understand what happens inside an electric motor when you push it hard. The rotor is the spinning heart of the system, and as it accelerates, centrifugal force builds inside it violently. At extreme speeds, that force tries to tear the rotor apart from the inside out. Most conventional rotors simply can't survive that kind of stress. They warp, they crack, or they fail outright, which is exactly why automakers have historically kept RPM ranges conservative and leaned on bulky cooling systems to keep things stable. Tesla's answer was to wrap the rotor in a shell of carbon fiber, the same category of material trusted in aerospace and motorsport for its unusual combination of strength and near weightlessness. That wrap acts like a cage, holding the rotor together even as it spins at speeds that would tear apart a traditional design. Reports on the technology suggest these units can spin at speeds in the tens of thousands of RPM, a range typically reserved for specialized industrial equipment, not a family sedan idling in a school pickup line. But raw spin isn't the interesting part. The real story is what that stability does to efficiency. A rotor that isn't fighting to hold its own shape wastes far less energy as heat and vibration. More of what comes out of the battery goes directly into moving the car forward instead of leaking away as waste. That single shift is what lets a motor be both blisteringly quick and impressively efficient at the same time. The exact combination the industry had quietly decided was off the table. You can see the result of this thinking in Tesla's highest performance vehicles, where multiple motors working together have delivered acceleration numbers that used to belong exclusively to million-dollar hypercars, all while the vehicle in question is still, underneath the drama, a practical family car with real range and real cargo space. That's the part that unsettles competitors. Building something absurdly fast is one challenge. Building something fast, efficient, comfortable, and affordable enough for ordinary buyers is an entirely different and much harder problem. And it's the one Tesla appears to be solving first. Here's the piece that makes this even more difficult for rivals to catch up on. Even if a competitor understood exactly how the carbon-wrapped rotor worked, replicating it at scale is brutally hard. Wrapping carbon fiber around a spinning rotor under precise tension isn't something you can eyeball. Wind it too loosely, and the rotor flexes and fails under load. Wind it too tightly, and the fibers themselves crack. Get the curing temperature or timing wrong, and the entire part is scrapped before it ever reaches a car. Every finished rotor then has to be balanced to a tolerance most factories have never had to think about, because a wobble invisible at ordinary highway speeds becomes a violent, self-destructive vibration at tens of thousands of RPM. In other words, you can't reverse engineer this from a photograph. A competitor would need to rebuild an entire manufacturing process from scratch, absorbing years of failed rotors, wasted material, and expensive trial and error along the way. The exact same painful process Tesla has already paid for and moved past. Industry watchers have suggested that catching up on this specific piece of engineering alone could take rival automakers the better part of a decade. It's worth asking why Tesla chose to reveal something this significant now, rather than saving it for a splashier moment. Part of the answer lies in the pressure building elsewhere in the company. The Cybertruck, once positioned as a symbol of Tesla's ability to redefine an entire vehicle category, has underperformed relative to the enormous hype that preceded it. Sales have lagged behind early projections, recalls have chipped away at consumer confidence, and a meaningful share of registrations reportedly came from Tesla-affiliated entities rather than independent buyers. For a company whose brand depends on the idea that everything it touches reshapes its category, a stumble like that carries weight beyond the balance sheet. It raises uncomfortable questions about whether the magic still works. Against that backdrop, a breakthrough in core vehicle engineering, something that can't be dismissed as styling or marketing, becomes exactly the kind of proof point a company under pressure needs. It shifts the conversation away from one disappointing product and back toward the underlying technology that touches everything Tesla builds. And that underlying technology is where things get genuinely uncomfortable for the rest of the industry. Tesla isn't just chasing performance with this new drive unit family. It's chasing manufacturability. The company has reportedly set an internal target of producing an entire drive unit, motor, gearbox, and power electronics combined, for close to $1,000. Compare that to competitors who, by some estimates, spend 3 to 5 times that amount to achieve similar performance, and you start to see why this matters so much more than a single spec sheet. Multiply that gap across hundreds of thousands of vehicles a year, and you're not looking at a minor cost advantage. You're looking at margin that can fund entire new product lines, while rivals are still trying to break even on their electric lineups. That cost advantage isn't standing still, either. Tesla has been working to reduce its dependence on rare earth materials like neodymium and dysprosium, elements whose supply chains are concentrated in just a handful of countries. That concentration has long given a small number of suppliers outsized leverage over the cost and availability of motors across the entire industry. If Tesla can meaningfully shrink its reliance on those materials, it doesn't just save money. It steps partly outside a web of supply chain risk that its competitors remain tangled in. The same logic applies to reducing dependence on costly semiconductor components in the power electronics, another area where Tesla has been quietly working to cut both cost and outside dependency. Meanwhile, the rest of the industry is not exactly thriving. Traditional automakers with genuinely capable electric vehicles have still struggled to turn a profit on them, often losing significant money per vehicle sold even as they build out increasingly competitive lineups. Newer EV-focused companies have faced their own struggles, keeping production costs under control despite strong initial buzz and investor enthusiasm. Even massive global players have hit delays, software headaches, and growing doubts about long-term profitability in their electric divisions. Only a handful of manufacturers, most notably in the lower cost segment, have shown they can compete with Tesla on scale. And even then, largely by competing on price rather than matching the combination of performance, efficiency, and margin Tesla appears to be building toward. This is really where the story stops being about a single piece of hardware and starts being about something much bigger. Tesla's motor doesn't exist in isolation. It feeds directly into everything else the company is building. Every additional Tesla sold, because of a cheaper, more efficient drive unit, is another vehicle collecting real-world driving data. That data trains the software systems behind Tesla's autonomous driving ambitions, and better software makes every Tesla on the road more valuable, which funds further hardware development, which makes the next generation of motors even more capable. It's a loop that feeds itself, and every additional turn of that loop makes it harder for anyone starting later to catch up, because they're not just behind on cars, they're behind on data, behind on manufacturing experience, and behind on the infrastructure needed to compete on all of those fronts simultaneously. The company's charging network tells a similar story. What was once dismissed as a nice perk for existing owners has become genuine infrastructure that competitors now rely on. After years of unreliable and confusing alternatives pushed rival automakers to adopt Tesla's charging standard for their own vehicles. Every time a competitor's car plugs into that network, Tesla gathers more data on usage patterns, demand, and hardware performance, even when the actual vehicle sale went to someone else entirely. Step back far enough, and it becomes difficult to describe Tesla as simply a car company anymore. It looks increasingly like a technology company that happens to use vehicles as its entry point, one built around energy systems, in-house computing, proprietary software, and a growing mountain of real-world driving data that few, if any, competitors can match. The carbon-wrapped rotor, sitting quietly inside its latest drive units, isn't the headline on its own. It's the mechanism that makes everything downstream possible. More affordable vehicles, more vehicles on the road, more data flowing back into the system, and a widening gap that gets harder to close with every passing year. Whether that gap is permanent is still an open question. Manufacturing advantages can erode. Rivals can surprise you. 10 years is a long time in an industry moving this fast, and plenty of dominant technologies have eventually been matched or leapfrogged by competitors willing to take a completely different approach. But for now, the companies chasing Tesla aren't just trying to build a comparable motor. They're trying to rebuild an entire manufacturing philosophy, absorb years of costly trial and error, and do it all while Tesla keeps moving the target further away. So the real question isn't whether this motor is impressive. It's whether the rest of the industry can find a way to compete on more than one front at a time. Because right now, it looks like Tesla isn't just building a better engine. It's building the foundation everything else gets stacked on top of.